Okay, so you just finished up the assignment on the history of the atomic theory. So now let's just talk a little bit about the actual atoms. Okay, so if you look at these three pictures of gold, okay, you have one that's gold dust, one that's gold bars, and the other is just a piece of raw gold. Okay, gold. So are do each of these have the same properties as each other? Yes, we just got finished talking about physical and chemical properties. All of these we would still classify as gold and having those properties. But the question is there a point at which gold can be broken down so small that the particles do not retain those properties? This is kind of what Democritus was talking about. You can break something down to the point where it can't be broken down any further and still be what it is. Okay, so if you had a gold ring and you ground it down into dust, would it still retain its properties? Yes, you could continue to break it down until you could no longer break it down any further. At the point that it loses its properties of gold, that's when you've gotten to the atom. Okay, so how small is a typical atom? Think about the size of the earth. Okay, um, we're going to talk here about the fact that this is the size of the earth in comparison to the size of a penny with the earth. That's how small an atom is in comparison to the penny. Okay, so just really small. In fact, if you took a whole bunch of copper atoms that have a diameter of 1.28 times 10 to the negative 10th meters, and you placed those out, okay, 6 billion of them lined up side by side, it still would not be as long as the meter sticks that we have in the classroom. So just atoms are really small, okay? All right. They're so small, in fact, that we need the technology of the scanning tunneling microscope, STMs, to give us a picture like this one of the atom. Okay, and really, this invention allowed us to see what all of those scientists that we talked about before were just theorizing about. So now we know the history of it all, we know what it is, we can see it. So the question that science has now is what do we do with that information? How can we apply it? So not only can scientists now visualize the atom, but they can make a move, they can manipulate them, they can make shapes, patterns, and even simple machines in theory. So, this whole new science that's come about is called nanotechnology. Okay, the promises of nanotechnology are things like being able to atom by atom manufacture molecules that can work as machines. Okay, this is still in the future, so don't get too excited about what could happen. But it is something that will happen. The question that we need to ask ourselves as scientists always is number one, should we be doing what we're trying to do? And number two, if we can do that thing, will it actually be beneficial to society? And those two questions I want you to really think about. I want you to also start thinking about what are practical ways that we could implement nanotechnology? What are practical ways that we could put atoms together, atom by atom by atom, to make molecules that could be beneficial to people? All right, so think about that. Okay, so our overview here, we talked about the creation of the atomic theory. This was a big step in our understanding of atoms. But like all science, once it's accepted, it's led to further questions like what is an atom? How are atoms shaped? Is the atom composed of smaller molecules? Um, and all of this has really taken hundreds of years to come about. So um, I hope you've enjoyed these two assignments. I want to make sure that you've answered all the questions from them, and I'll see you in class tomorrow.